Alright, this is chapter 8, problem number 6. The problem is the mass of a regulation tennis ball is 57 grams, and tests have shown that the ball is in contact with the tennis racket for about 30 milliseconds. The fastest known tennis ball was served by Big Bill Tilden in 1931, and its speed was measured to be 73 meters per second. What impulse and what force did Big Bill exert on the tennis ball in his record serve? So in order to do this, we first need to find the momentum that he has, so we have PAS, which is the momentum after serve, which equals mass and velocity after serve. Mass is 57 grams, or 57 times 10 to the negative 3 kilograms. So we plug in the numbers, which give us 4.16 kilograms after we convert back. So we have that equals 4.16 kilograms mass per second, or meters per second. Also, just as a side note, the velocity before the serve is 0, so our momentum before the serve is also 0. So essentially, the change in momentum is 4.16 kilograms per meter per second. So in order to find force, we take the joules over change in time, which is 4.61, over the amount of time that is in contact with the racket, which is 30 milliseconds, or 30 times 10 to the negative third, which equals 140 kilograms per meter per second squared, or 140 newtons. So we find that the impulse is 4.16 kilograms per meter per second, and the force is 140 newtons. So for part B, the question is, if Big Bill's opponent returned his serve with the speed of 55 meters per second, what force and what impulse did he exert on the ball, assuming only horizontal motion? So after ASR stands for after serve is returned. So PASR equals mass times velocity ASR. So we have our mass again, and we have our velocity again, which is now going in the opposite direction, which makes this negative. Velocity or momentum of the ball before the serve is returned is equal to essentially it's the same thing that we found up here after the serve is returned. So we can find the difference in momentum, we can find the difference in the two essentially by plugging in 4.16 for P for momentum BSR. Anyways, so we plug in the numbers for this, which gives us minus 3.14 kilograms per meters per second. So our impulse is, again, momentum after serve is returned and before serve is returned. So minus 3.14 minus 4.16, which equals negative 7.3 kilograms per meters per second. And then, so that's not quite our answer yet, but so in order to find the force, we again plug in the impulse over change in time, which is minus 7.3 over 30 times 10 to the negative 3, which equals negative 240 kilograms per meter per second squared, or negative 240 newtons.